So I feel like we've gotten pretty good at identifying where our vertical asymptotes will be, where our horizontal asymptotes will be, our intercepts, and then even our end behavior. I want to start with a mnemonic device. I just read about it on a Facebook group that I belong to for calculus teachers, and it was very heavily debated whether or not this was a good mnemonic device or whether it was just kind of rubbish. I always struggle with remembering where and how to find your horizontal asymptotes and vertical asymptotes. And so when I saw this, I thought, I think this is going to be helpful even for me. You know, you use it once a year for a couple of weeks, and then it's not something that shows up in math quite a bit. So I'm going to throw this at you, and maybe it'll stick, or maybe you'll think it's just too silly for your brain space. But the mnemonic device is Bobo, Button, Eats, DC. I don't know, sounds like a horror movie or something, doesn't it? So Bobo, let's start there. What does that stand for? It stands for bigger on bottom. Y equals 0 will be your horizontal asymptote. Bottom, B-O-T-N, stands for bigger on top, no horizontal asymptotes. And then finally, Eats, DC. What does that stand for? It stands for each, or the exponents, I guess each of the exponents, or the leading exponents are, oh, I forgot my S. Eats, S stands for same. So let me erase and fit in my S. So exponents are the same. DC stands for divide. And C, the constant. Okay, let's see if this helps us at all kind of figure out what our asymptotes will be. So for our additional example, we have this function g of x. So what I see right now is that we have a bigger exponent on top. So bigger on top means no horizontal asymptote. Okay, so what do I do? Horizontal asymptote, none. So then what I'm going to do is do some long division. And here goes my long division. X minus 1 goes into x to the third minus 3x squared plus 3x plus 1. Could I be doing synthetic division right now? Actually, I probably could, because my x minus 1 term is just, or chunk is linear. Anyway, I'm going to keep going. X squared, x cubed minus 1x squared. Draw a line, change the signs, cancels. Negative 2x squared plus 3x plus 1. Repeat the process. X goes into negative 2x squared, negative 2x times negative 2x squared plus 2x. Draw a line, change the signs. I have 1x plus 1 left over, so then plus 1. And then 1x minus 1, draw a line, change the signs, cancels, and we're left with a remainder of 2. So this is plus 2 over x minus 1. Okay, so I don't have any horizontal asymptotes, but that doesn't mean I don't have any asymptotes at all. So as I divided, I came up with this new polynomial function, x squared minus 2x plus 1 plus 2 over x minus 1. So this is going to be something that will tell us about the rest of the function. I'm going to call this part the rational function. This is the rational function part. And this part is going to be our asymptote. Now, not only is it not a horizontal asymptote, it's not even a slant asymptote, it's going to be a parabolic asymptote. What? That is crazy talk. Well, it's going to be pretty cool is what it's going to be. Okay, so what else can we say here? We have this parabolic asymptote, that's for sure. We have a vertical asymptote at x equals 1. We can talk about the x-intercept and the y-intercept. Let's do that real quick. So for my y-intercept, remember I'm going to plug in 0, and what will I get out? I will get out 1 minus 2. I will get out negative 1. So I'm going to let you just think through that. Plug in 0 and you'll get out negative 1. 0 minus 0 plus 1 is 1. Plus 2 divided by negative 1, which would be negative 2. That's negative 1. Okay, and then my x-intercept. My x-intercept will be my x-intercept. I don't believe I'll have any x-intercepts. Nope, because I don't have any unique zeros in my numerator. So I'm going to even just kind of make myself a note there. I had no unique zeros. I should say real zeros of the numerator. Put that in a thought bubble because I kind of thought about that. Okay, let's make a sketch. Here we go. What should we graph first? Let's graph our y-intercept down here. I don't have anything to graph as far as an x-intercept goes. I can put my vertical asymptote at x equals 1. X equals 1, here's a vertical asymptote. And then I just need to go and graph that parabolic asymptote. So check this out. To graph this parabolic asymptote, y equals x squared minus 2x plus 1. I don't know how to graph that right off the top of my head. I would really like this to be in vertex form. To put this into vertex form, I can complete the square. X squared minus 2x plus something. Push that plus 1 off to the side. If you're going to add a square, remember to subtract that square. Half of negative 2 is negative 1. Squared is 1. So there's your what it takes to complete the square. And then now this is going to factor into x minus 1 quantity squared plus 0. This parabola is shifted to the right 1 and up 0. I'm going to go to the right 1 and up 0. And then here is that asymptote, like so. And then from there, it's time to just draw in the curves. So my curves are going to hug these asymptotes like so. And then I'm going to come over here and hug this part too. So if you're saying, like, how did you know that? Well, I'm going to tell you. I looked at the graph, and I saw that that's kind of where my curves were happening. So you're probably then saying, yo, lady, why did you do any of the work at all if you could just look at the graph? No, we need to understand where these asymptotes come from and how they're calculated. So we just take a sneak peek to see where the curves belong, but you have to understand the math behind the asymptotes. Okay. So there we have our picture. Now, let's talk about some of the characteristics here. Let's start with end behavior. Let's talk end behavior. So what is the function doing, or what limit is the function approaching as x heads towards negative infinity? Well, it looks like our function is heading off to positive infinity. What is happening to the function? What is the limit of the function as x approaches positive infinity? Well, we're heading toward positive infinity again. We can make two more limit statements. So this talks about the end behavior, but now at asymptotes, what's the function doing? What is the limit of the function as x approaches 1 from the left? Well, the function is heading toward negative infinity. What is the function doing as x approaches 1 from the right? Well, in this case, as we approach 1 from the right, the function is heading toward positive infinity. Let's talk domain and range next. So what's the domain of this function? Well, anything from negative infinity to 1, step over that asymptote, and then 1 to positive infinity is also fair game as a possible input to this function. We just can't plug in 1. Now we would have known that by just looking at the original function. If you plugged in 1, you're going to have that domain restriction where we're trying to divide by 0. The range. What is our range? Well, it looks like we can get anything out of this function. We can get out anything from negative infinity to positive infinity. So you're probably saying now, wait a minute, how could we get out a 0? Well, remember, we can get out a 0 if we have, you know, something like 0 over 1. And we do have that possibility based on our various values of x that we might be plugging in. So we talked domain, we talked range, we talked about the end behavior. Oh, you know what? Let's talk about where the function is decreasing. So notice that our function is decreasing from negative infinity to 1, and then also from 1 to 2. Now, I knew that because I looked a little bit more closely at the graph on my calculator. The function is increasing from 2 to infinity. There's no symmetry. This function is unbounded. There is an infinite discontinuity. There is infinite discontinuity at x equals 1. I think by this stage of the game, you guys recognize that infinite discontinuity. We've talked a lot about that. Okay, so let's stop there. Turn your paper over, and on the back side, you have a nice empty sheet of paper, right? Right. Okay, so let's see what we can do here. So work with me. If you want to stop the video right now and try to do this all by yourself, you are more than welcome to do that. So Bobo Botan eats DC. Oh, what's going on? Well, here our m is equal to 2 and our n is equal to 1. So that means that we are bigger on the bottom. Since we're bigger on the bottom, y equals 0 is going to be our horizontal asymptote. Y equals 0 is a horizontal asymptote. Good to know. I don't need to worry about any of the rest of that crazy acronym, or I don't know, acronym, mnemonic device, whatever you want to call it. We talked about it in the first example, g of x, and now we're talking about it again in f of x. So we know what our horizontal asymptote is. We can talk vertical asymptotes next. This would factor into x minus 3 and x plus 2. So our vertical asymptotes are at x equals 3 and x equals negative 2. Vertical asymptotes. Something else we need to know is our intercepts. Our x-intercept will be the unique zeros of the numerator. So that will be 1, 0, because x equals 1 would be a 0 of the numerator. Our y-intercept, if I plug in 0, what will I get out? I'll get out positive 1/6. Okay, I think we're ready to graph. Let's do it. So y equals 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3. Okay, rough sketch. Y equals 0 is my horizontal asymptote. I'm glad to be using these various colors. Really helps me see what I'm looking at. X equals negative 2. X equals 3. Y-intercept at 1. No, x-intercept at 1, I mean, right there. Y-intercept at 1/6, right about there. And then from here, I believe I'll be doing something like that, and then something like that. So opposite behavior, I'll be having opposite behavior kind of right in here. I have opposite behavior in there. I'm going to delete that now. I just wanted to show you what I was talking about. And then that opposite behaviorness helped me kind of figure out like how to draw in those curves. Okay, so can you do the majority of that, most of it without the use of your calculator? I'm going to plug my calculator up here on the board. And then let's take a look at the actual picture. All right, so here comes my calculator. Remember, you have this app on your Chromebook, so please use it if you can. So on the top, I have x minus 1 divided by, on the bottom, x squared minus x minus 6. And if I graph it, beautiful. That's exactly what I thought. So I'm going to turn my scatter plot off. No need for that today. And here's my graph, and that is pretty close to what I estimated. All right, we can write all sorts of limit statements. I guess I can actually, let's see, 1, 2, 3, 4, 5. I could write 6 limit statements. I'm going to stop now. You can write those limit statements. You can tell me the end behavior, so what's happening as we move to the left and to the right. You could define the domain and the range. You could talk about where the function is increasing or decreasing. And actually, as I say that, this function is decreasing over the entire domain. Never does this function increase. Let's see, what else can we talk about? Increasing, boundedness. This is also unbounded. Okay, good place to stop.